pick up that conversation around water. Professor Anthony Turton is an expert on water and water systems. Professor Turton, good afternoon to you. We were talking to the National Department of Water Affairs a few moments ago and talking about how much water we lose. We lose in Gauteng alone around 42% of our water. How can we fix these water systems? Can they even be fixed?
Yes, good afternoon to you and the listeners. Yes, you must appreciate that water systems are designed for a particular lifespan. You must also appreciate that pipes come in lengths and they have to be joined. And at every joint there's a potential point of failure. So when the systems start to fail and you fix one pipe, then you start putting pressure on the next joint and you typically start seeing a cascading effect. And I don't know if the listening public knows this, but when pipes are put under pressure, they swell up and they shorten. So when a pipe is under pressure, it is shorter and fatter than when it's not under pressure. So each time you lose pressure in a pipeline system, you start changing that profile. But this becomes a knock-on effect because one length of pipe impacts on the next length of pipe, and eventually it becomes hundreds of kilometers of pipe that are impacted. So you get a cumulative linear impact over the whole length of the pipeline, and this, of course, just accelerates the failure throughout systems. So bottom line is that systems that were designed lifespans, and once you start repairing a system, then you normally start seeing an acceleration of failures around that repair job. That's just the way that pipelines work.
So you can't repair them, you have to replace them.
No, you can repair them, but ultimately it gets to a point where firstly they've got to be repaired properly under supervision of an engineer and with a proper design repair. So very often the kind of repair that we see is just a patch. They normally just put a metal patch over the leak with rubber in between it, and they put a compression fitting or compression band on it that just basically squeezes the leak and closes it. Now that's not a repair. That is a temporary job, and very often those temporary jobs are left in as permanent repairs. So it comes down to two factors, I guess. The first factor is what is the design life of the system? Are you at the point at the end of that design life or not? Then you've got one set of decisions that you make. The second thing is what is the design of the proposed solution? Is it an appropriate design? And the third thing is it supervised by appropriately qualified professionals? Those are the three things that come into play. And when it gets to the point in time where the cost of repair simply starts exceeding the value of the asset under management, at that point in time you then start looking at replacing the whole asset. But that's just how it happens all over the world, and South Africa is no exception.
Does it mean, it reminds me a little bit about load shedding. If you keep switching the power off and on all the time, the substations actually have a much shorter lifespan. You eventually break systems. If we have a water shortage, say for example in South Hills and Joburg you had water on and off for a period of 2 months, or for 2 months at one point, that means that those pipes will be under pressure, then not under pressure, then under pressure again. As you say, they get sort of shorter and fatter when they're under pressure. They'll contract and expand from time to time. So when we have a water problem, we're actually also having a big impact on the water infrastructure.
Yes, correct. So in the electrical system, your transformers go under load and off load, on and off load. That impacts various things in the transformer. And of course also the switchgear. The switchgear is only designed to be switched on and off so many times, and then it fries up because each time it switches on and off, there's a massive spark that happens. So you can only do it certain number of times, and then that's it. That's fine. Now, in the case of pipes, it's slightly different, but in the case of pipes, it's about the pressure system is designed to be under pressure, and if you fluctuate that pressure too much, each time you change the pressure, you get this creeping effect that I referred to now, and that becomes a linear progression. But of course, there are parts designed into the system to absorb that expansion. And if you ever go to an industrial plant, you'll see, for example, steam pipes that got bellows in them, for that very reason. And certain pipes have got big sort of U-shaped bends in them. You see it, for example, in those big oil pipelines that go through the tundra. They've got these big sort of S-shaped bends in them. That's all for expansion. So it's a well understood phenomena, in the engineering community. But this is where the second part of my comment comes in. Is this thing designed? Is it an appropriate solution when you patch something? And the third part, is it done under the supervision of an adequately qualified engineer? And those are the two areas that we're falling short of.
So one of the things is that all of this is going to require to do this properly. And there's a reason that people put a patch. They put a patch because that's the resources resources they have at the time, right? So then you're going to need a lot more money to do this properly, in some cases to replace certain parts of the infrastructure. Councils don't have money, Professor Turton. I don't need to tell you that. So then could we actually be facing quite a difficult situation in the near future?
Yes, you're entirely correct. Councils don't have money, and part of the reason why they don't have money, I mean, there are many reasons, but one of the reasons is because one of their biggest single revenue generators is the onward sale of water. Remember, councils buy water from wholesalers, Rand Water in this case, and they sell on to the end user, the retailer. So they are retailers. Councils are retailers of water. They buy water at 12 Rand a cubic meter and they sell it at 30 Rand a cubic meter, whatever. So for every cubic meter of water lost, that is lost revenue to the city. So let's just round it out and say we're approaching 40-45% of non-revenue water. That means 40 to 45% of the budget that is being potentially amplified, by the wholesale retail number dynamic. That is being lost to the councils. So, yes, entirely. The more water you lose down the drain, the closer you come to bankruptcy. It's as simple as that.
Professor Anthony Turton, thank you very much indeed at the University of the Free State. Do appreciate the time.